next thing we want to talk about is linear transformations. Excuse me. So, now first of all, I have a set of vectors that I'll just designate by S equals set notation, and I have 1, 2, 3, 4 column vectors. Now, I've kind of color-coded these. I've got a purple underline here, an orange underline here, green here, blue here. And I've sketched the corresponding vectors here. So that 1, 0, we go from the origin out to the point 1, 0. 0, 1, we go from the origin to the point 0, 1. Point 875, we come up point 87 and up point 5. And you should recognize point 87 as an approximation of the square root of 3 over 2, which is what? It's the cosine of 30 degrees, right? And point 5, point 87 here. This vector would be at 30 degrees. This vector would be at 60 degrees. We just plot the point 0.87, 0.5, and the point 0.5, 0.87. And the two vectors are going to be very close to the 30 degree and 60 degree position relative to the positive x-axis in the counterclockwise direction. Okay, so these are our 4 vectors. Now we're going to transform these vectors using a matrix. And the way we do that is very simple. Now the analysis of a transformation, especially in higher dimensional spaces, can get really, really hairy. And we have to develop all kinds of machinery, and we're all going to be able to develop just a little tiny bit of that during this class, because linear algebra is a huge subject. Anyhow, T1, we're going to call this T sub 1, transformation 1, and over here we're going to have a transformation T sub 2. Now, to illustrate the transformation, we're going to use these 4 vectors. So the transformation is defined by a matrix that I'll call A. I'll call this one A. I'll call this one A. Since this A is on this side of the board and this A is on this side of the board, hopefully that won't cause any confusion. Okay? And the transformation is this. We multiply the matrix A by the vector V, each of these vectors in turn, and we get the transformed vector. So we could write that T1 of W, function notation, T1 of W equals A times V, this A. I could call this A1, call that A2, and you can do that if you want. Might not be a bad idea, but I'm going to stick with what I've got here. Okay, so, well, V is going to be one of the vectors in S. Now, V could be any vector in the entire plane, but we're just going to use the vectors in S, and you'll see to some extent why we do that. Okay, so A multiplied by the first vector in the set V is just A times the column 1, 0. So, well, A is just this matrix. So if we multiply this matrix by the 1, 0, what do we get? Well, first row times first column just gives us 0.8, and that should be clear. And if you're not fairly clear on matrix addition or multiplication, you want to maybe think about that a little more. But again, this is just an introduction. It's a very straightforward calculation that you probably understand from what you've seen before. If not, I have plenty of practice, so don't worry about that. Okay, then the second row times this column, 0.6, 0.8 times the 1, 0. Yeah, 0.6 times 1 is 0.6. 0.8 times 0 is 0. 0.6 plus 0 is 0.6. So we get, excuse me, this result. Okay, now, we do the same thing with the vector 0.87, 0.5. I've got these colors wrong. I'll fix that in a minute before we draw the picture. I've got these colors reversed here. And I've kind of got these out of order, but okay. I go to the 0.87, 0.5, and that's a 0.5. Looks like I didn't put my decimal in there. Okay, well, now we've got to multiply the same matrix, the matrix that defines our transformation, by 0.87, 0.5. Okay, well, let's see if I can do a little mental arithmetic. 0.8 times 0.9 would be 0.72. 0.8 times the 0.03 that this is short of 0.9 is 0.24, and 0.72 minus 0.024 is 0.696. And check my arithmetic on that. 0.6 times 0.87, well, 0.6 times 0.9 is 0.54, and 0.6 times 0.03 is 0.18. If you subtract 0.018 from 0.54, you get 0.524. No, you get 0.522. As I say, watch my arithmetic. I'll think it right, and then when I write it down, you see what happens. Well, now I'm going to go ahead and do these next two calculations, but you should go ahead and do them. I'll do these in a separate video, so you don't have to sit there and watch me struggle through the arithmetic. And then you can check my arithmetic because you will have already done it. Then we're going to come over here and do the same thing with this transformation. And of course, what are we going to have? We're going to have A multiplied by what? The vector 1, 0. Then that's going to equal what? It's going to equal 2, 0, 0, negative 3 multiplied by 1, 0. And what's that going to equal? Well, you can easily see what that's going to equal. I'll write it out while I'm offline, and then I'm going to do the same thing with this vector, and this vector. I'm also going to try to fix this picture, make this one orange and this one green, because that's the way they should be.